Hello, welcome to this IGCSE talking paper. Now this is for the EdXL physics course, and we're looking at a question that's typical of one you might get for section A5, the turning effect of forces. Let's have a look, shall we? Now this takes me back. Photograph C shows a student using an old camera. That dates me, doesn't it? I used to use these cameras. Uses film, this strange thing we used to use back of a camera called film before we had digital cameras. Now it says the film is pulled through the camera using lever A. So here is lever A, okay, and what you would do, you would pull it. So you pull it with the force, okay, in that direction there, okay. Student pushes on lever A with a force at 7 newtons. Now the force is applied 0.04 meters from the pivot. So from the pivot here to the point where it's being pulled is 0.04 meters, okay. An easy bit, state the equation linking a moment with force and distance. It's very straightforward, just write out the equation. Now use the equation you've just quoted to calculate the moment the force that turns lever A and give the unit as a mark for that. So remember you had a force of, 7 newtons? You had a distance of 0.04 meters. So actually you can use that in meters, or if you want to you can change it to centimeters, which would be 4, wouldn't it? But be careful about the unit if you do that, okay? Next, okay, now when all the film is finished up, when all the film is used, you had to put it back through the camera using another lever. So a little lever here used to flip up, and you would then turn this and you'd pull all the film back through the camera and send it off to be processed. Now the force acting on lever R is only 0.02 meters, so it's a much shorter lever, okay, so that there is 0.02 as opposed to 0.04. So explain why the minimum force needed to lever R is likely more than 7 newtons. Assume it's the same moment, but so why would the force be more than 7 newtons? So pause the video at this point and see how you get on. Okay, first one, it's very straightforward. State the equation. You should love these. State the equation. Learning equations is easy. Moment is force, which is being applied here, times perpendicular distance is distance at right angles, which is this one here. So you've got right angle there, okay. Perpendicular distance, you actually don't need it. If you ever see this in a mark scheme in brackets, it's a word you don't need. You don't need to include it, but you do need distance. From the pivot, again, not needed, but helps explanation. Now we're going to use that formula to calculate the moment. Okay, the moment, use big M for moment, equals force times distance. Okay, so it's 7 times 0.04, if we're sticking to meters, which is 0.28 Newton meters as a mark for that, so don't miss it off, or 0.3 if you round it up. If you use centimeters, so you could use 7 again, it's 4, which is 28 or 30. This one is Newton centimeters, so make sure that you use the correct unit in either case. Okay, so that's some easy marks there. Last bit. Now this is all to do with the fact we are shortening a pivot. We've got a much shorter pivot here than we had on the other side. So how is this going to affect the force? So explain on a minimum force needed to turn R more than 7 newtons. Now remember our equation, the moment equals force times distance. Okay, so the length of the distance to pivot is less than lever A. Remember that lever A was, what was it, 0.04, and lever R is 0.02. So more force is needed to cause the same moment, i.e. force is the same, moment be less. So what happens here is, in order to keep the moment the same, if you want to keep that the same, I'll put equals there. Okay, if the distance goes down, which it is, distance going down, isn't it, from 0.04, 0.02, to keep the moment the same, if this one goes down, the force must go up. So there we've shown there, it's more than 7 newtons. Okay, just read through that again so you understand why that is, but it's pretty straightforward. So thanks for doing the question. Question for you is, how did you get on? Thank you for listening and watching, and I'll be back again with another question very, very soon. So bye bye for now.